Hello, everybody, and welcome to the Geometer's Compass. This is Geoff in Dublin, in Ireland, with
Scott in Victoria, Canada. And
today we are very excited to be on podcast number 11. Can you believe it already? You know, these do begin to clock up after a while. And today, Scott and I have decided to talk about the line, the line meaning the distance between 2 points, which is going to bring us on to the archetype of two-ness or duality. And back at the very beginning, I don't know what episode it was, but we did a podcast on the circle. And we have an aspiration to do a podcast on each of the numbers 1 to 10, all the way through the decade. And I think at the start, we might have thought we were going to go sequentially, but we ended up having all these wonderful guests and, going from topic to topic. So I don't think it's going to be a episode by episode journey through the archetypes, but maybe in time we can do a playlist or something of them, It doesn't really matter, I don't think, But today, are you in the mood to talk about lines, Scott?
Yeah, I have a few ideas about lines that I'd like to share and see if we can stimulate an interesting discussion about it. I mean, it seems like a one-liner, really. It doesn't seem like...
But we are nerds, aren't we? Like we actually are nerds, Hey, you want to get together and talk about a line?
Yeah.
It's like, really? Yeah.
It's
but
like,
it actually...
let's talk about the letter A. It's like kind of like... I mean, lines are such an important thing in geometry, and oftentimes we just sort of take it for granted. But I kind of want to tease that apart and try to understand what a line is. And I think to understand that, you have to go back and listen to our podcast on the circle, because I feel that lines really only emerge after the circle, Like if you were creating a universe, I think the first movement you would make would be some kind of circle, right? A boundary that's equal in all directions. And then the line emerges as a relationship between circles, between their intersection points, and maybe the first movement would be the vesica piscis or vesica piscis shape, which is two circles, and each circle has its center on the other circle.
And it creates that beautiful almond shape. Yeah.
And then where they intersect, there's a above and a below point, and that leads you to draw a line. It's clear that just by connecting the intersections or connecting the dots, you get a line. And the line is a very efficient structure because there's no nonsense. It just goes from point to point. It doesn't meander. It doesn't get off track. It's just very literal, And so it has that quality of being like, in some way, a simplification or almost like a lower dimension. In a very real sense, it is a lower dimensional form because the line is one dimensional. It has length only and no breadth. In fact, that's how Euclid defined it. It's a length without breadth. Whereas a circle occupies a two-dimensional plane. So it's a two-dimensional object that has area. The line can't have area. And so it's a simpler thing by far, And I was thinking on lines and circles, and then I was thinking about the cosmos and how what is the universe sort of consists mostly of what? Stars. That are separated by great distance, and the stars in themselves are circles or spheres, right? So we have circles everywhere, and light that emanates from the stars goes in lines, doesn't it?
Yes. Yeah. Nice. Yeah.
And these are the tools of a geometer. What are the two main tools of any geometer, Geoff?
Well, it's the compass and the straight edge, isn't it? A tool that draws circles and a tool that draws lines.
That's it. So with those two tools, you can actually construct any geometry. Any kind of constructible geometry is done just using those two tools. And for that, it's very beautiful in how simple it is. I mean, how many things in life do you just have like two tools
Yeah, yeah, yeah.
Yeah.
I like actually, to be honest, I know we made a little joke about like talking about lines and how could we make a podcast out of that? But just as you were talking, it was kind of reminding me about the two aspects of geometry, that you have this kind of, on one level, this quantitative way of looking at it, like it's just a line, it goes from point A to point B, no big deal. It doesn't really have a lot to it. But then when you actually get into the qualitative aspects of these archetypes, and just as you're speaking so beautifully about the distance in the vesica piscis or the vesica piscis, you begin to discover the qualities of two-ness, so like in the geometer's journey through number, it starts with the point and then it moves to the line. They're the first two steps, isn't it? And they're just like, I mean, they are fundamentally, would you call those opposites, the point and the line, Scott? Or are they steps in a sequence? Opposites never really works for me with
I wouldn't call
geometric
them
concepts.
opposites. I don't see the opposition there, because you
Mm.
could say a line is an infinity of points,
Hmm.
all in a line.
Yeah.
Or you
Yeah.
could say it's really the connection between two endpoints.
Yeah.
Yeah.
Yeah. So if you have an infinite line, it's just like it goes forever. That's one type of line.
Yeah.
Or then like when you have, the distance between point A and point B, it's very delineated,
That would be
isn't it?
called a segment.
Okay. Yeah.
Technically, that would be a segment, whereas a proper line extends infinitely, and a ray starts at a point and goes off in one direction infinitely.
Uh-huh. Yeah. Yeah.
But a line proper, it actually extends infinitely.
Yet, I don't know, maybe I'm wrong in this then. Maybe I kind of get mixed up with a segment and a line. But for me, when I get to the line, I kind of think of like two-ness and the number two, and it gives birth to the concepts of like duality, for example.
Yeah, well, I think that comes
polarity.
from the segment more than the line, but they're
Yeah.
the same family. And that comes from the vesica piscis having the two circles and
Mm-hmm.
from the two endpoints, right?
Yeah.
Yeah. And
Yeah.
also, when you can think, is it a two? But then when you think the symbol for one is a line,
Mm-hmm. Mm-hmm.
it's not a two. We don't write two when we're thinking of a line. We draw a line, and that ends up being the symbol one, which is
Does it
interesting.
though?
There's kind
Does
of a
it?
tension.
Because I think, okay, this is great. Now let's thicken the plot here a little bit, right? Because if I was to say, what is the first geometric form, like the one would be a circle in my head, and a two would be a line, and a three would be a triangle,
Mhm. Yeah.
you know?
Well,
So it's,
here's another thing to thicken the plot. A circle you might represent that as a zero, or maybe a point as a zero, a placeholder. Whereas
yeah,
a line could be a one, but taken together, 0 and 1 comprise binary, the concept of binary numbers, right? Zeros and
yeah,
ones, and that's
yeah.
base 2. So the base it includes all the digits within it. And so the line and the circle together kind of form a duality.
I'm just thinking, we're going to have to do a podcast on zero now, Scott.
Yeah.
Yeah, you know what I
Yeah.
mean.
Yeah.
But it does get kind of tricky and confusing in my brain actually when I think about these concepts. In a nice way. I really love this confusing trickery that numbers give me. But I totally get what you're saying, because 0 and 1 and that binariness, that is a very dualistic principle, isn't it?
Yeah, and I think that you need those circles in order to generate the line, in order to
Yeah.
have a two-dimensional surface in which to draw different lines. You kind of need to already have circles that define that plane. And so they're kind of inseparable in some way. And getting back to the concept of suns, stars, and rays of light coming out of them, right? You can't just say, well, there's the sun and there's no light. I mean, they're inseparable. there, anytime you have light, you trace it back to the source, and you have a sphere or a circle. And so they're and also the ray of light itself is both a particle that goes along the trajectory of the line, and a wave that waves all the way along the line infinitely. And when you look at a sinusoidal wave, and you get into trigonometry, and you understand that a little bit, what is a sinusoidal wave? But it's actually the up and down movement along the y-axis of a circle.
Okay.
As you trace around the circle with your hand, if you were to see where that was on the y-axis, it would be tracing a sine wave. And so, the wave-like nature of light, which travels in a line, is actually also tracing a circle.
Yeah.
Yeah.
Explain that to me again. So I understand how the particle, so light travels from the sun, and it can manifest as a particle or a wave. I kind of get that, and maybe I don't know the shape of particles, but I am guessing, are they spherical? Maybe
a
I don't know.
photon. I don't know that a photon has a shape. It doesn't have mass, right? I don't know either. Mass.
We need a physicist for that one.
But I don't think we know its shape, if it has a shape, but it is, you can think of it as like a point.
Yeah. It's like, it's possible it's a shape. I'm only joking. You know the way the physicists talk about that sort of stuff, It's possible we may know its location or may not know its location, and we may know its shape or not know its shape.
It's in an undisclosed location.
I love all that stuff.
Yeah.
Sorry, I was asking you a straight question there, though. So you were speaking about, I understand the particle, I understand the wave, but you were saying about somehow the wave form itself, this sinusoidal wave, is circular in its nature, but I didn't totally get that. Would you explain that again?
So if you look at trigonometry, it's the study of the unit circle. That is a circle with radius 1.
Okay.
And so the sign is actually the y value wherever you are on that circle. You can imagine the circle going around and a cross axis going through the middle of it.
Understood.
So the center of the circle is at coordinate 0, 0, right?
Okay. Yeah.
Okay. So as you go around the circle, it has a y value going up and down, right?
Okay.
And if you were just looking at the y value as you go around and around the circle, what happens is that goes up and it goes down and it goes up and it goes down in a sine wave kind of pattern over time.
Oh, I get you. Okay.
All right. And that's where we get the concept of sine and cosine. Sine is up and down, cosine is x-axis.
Wow, I'm learning stuff here. Yeah, I get it.
So it's really all these trigonometric relationships are really just the relationship of a circle and lines.
Yeah.
Okay, so there all of that stuff that helps us in practical ways, like how high is that telephone pole? Well, it's the angle that you see it, and the distance to the pole and all this stuff you may have learned in high school, and it has a practical utility, but it is all unpacked from the unit circle and its relationship with the diameter.
Gotcha. Yeah,
okay.
yeah.
And so that in itself is, again, a play of circles and lines.
Yeah, well, hey, that's one I do understand well, is the relationship of the diameter of a circle to its circumference. I mean,
there's pi.
Do you want to go there?
Well, that's another way that circles and lines relate. It encodes this miraculous transcendental number that we can never get to the end of, and we can never find a pattern in it. And it's just like one of the greatest mysteries of all.
Yeah.
And it seems like, wait a minute, it shouldn't be so mysterious. We're just drawing a freaking circle that has a diameter, and we really can't fully know and understand that relationship. It kind of mystifies even like super high level mathematicians. Pi is kind of a primary mystery in a way.
Don't you think that's one of the most kind of like powerful entry level red pill invitations of geometry, if you like, that when you begin to consider that, like, I remember speaking to you, Scott, about people trying to work out pi, and they had all these quantum computers and they're running it forever and ever and ever. And they're trying to see if they can even just establish a pattern in the never ending sequence of numbers, and they don't even find a pattern in it. So it's this like never ending number that runs on to infinity, never ends,
Every
never
year that
repeats.
they break the record. I think the last time I checked a year or two ago, it was at 50 trillion digits someone had calculated. And
And
somebody else
what
is
are they
going to try to
hoping
top
for with
that.
that, by the way? Are they
What's that?
hoping that like pi will get to the end and it'll go bing,
Yeah.
finally, this is it. We have pi complete. It's finished. We've got it. Everybody relax. It's over. Pi is resolved. Is that what they're hardly looking for that?
Well, I think
Are they
it's,
looking for a pattern in it, maybe?
I think they're just led along by their intuition. It's kind of like they would like to know the unknowable. And so they try.
Mm-hmm.
Okay. It's a human instinct to kind of square the circle, you know, to try to make these things that don't fit, to try to find some understanding of how they relate, you know, and it's sort of beyond us in a way. And yet it never seems to stop us from trying to figure it out, you know?
I totally agree with you. And I remember like I had this wonderful kind of strange experience one time about pi, about this very long before I got into geometry in the way I'm into it now. I think it was like maybe I was just out of college. I'd gone on a year of travel and I went to a physiotherapy session. I think I might have told this before on one of the podcasts but you know, I was coming down from this it was a beautiful fishing village here in Dublin, right? And I was just walking back to get the train actually. And I have no idea where this came from, but out of the blue, I just began thinking about pi. I remembered it from school or something. And I just went, is that true that pi, you know, the relationship of a diameter to a circle can't be worked out? Like, surely somebody's got to the bottom of that at this stage. Maybe when I was in school, it was unresolved, but I'm sure that's like all our computers and you look at Intel and all this carry on and quantum computing and, you know, all the fancy stuff. We can send probes to Mars and all that good stuff. And you have the neural lace and we're like superstars, you know. Surely we've resolved the conundrum of the relationship of a diameter to a circumference of a circle. I went home, I did some Googling, and then I just went, wow, like, hang on a moment, like just take a pause and actually think about what's going on there. You know, with all of the kind of the brains and the intelligence that exists on the planet, all of the power of all of the computers. If I'm right in this, it'd be great if someone like, you know, corrected me. But my feeling at the moment is that it's an unresolved mystery, you know? And for me, when I thought about it, it was like, so hang on a second, that relationship can never be resolved. It means there's something missing, right? 3.14 dot, 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 on forever to where, you know? And then it was almost like the more I thought on that and reflected on that, that thought form became like a magic carpet, you know, that just sort of like allowed me fly out of my kind of my rational beating my head against the wall. I have to know the answer. I want to know the answer. I really want to know, like that, like the quantum computer, got to work it out, got to work it out, got to work it out. I find geometry has this effect on me personally. And I think maybe on you, that like, I always want to know, I want to understand, I want to work it out. I want the answers to the mysteries of the universe, you know? And every time I try with geometry, I get certain insights and upgrades and I get really excited and I see all these correspondences and patterns, but I always get to a place where my brain, maybe I'm just not clever enough, you know, but my brain cannot handle everything that I'm trying to shore into it. And I hit this place of like, I actually give up. You know, I cannot work that out. I can't resolve the relationship between the diameter and the circumference. I don't know the solution.
Well, no one, I think no one can. And it was proven in the 19th century that you can never square the circle because we can't ever really rationalize pi. And so it's fundamentally impossible to solve pi and know the answer. It's not a ratio of two numbers. There's no algebraic solution to it. So it's transcendental.
Do you
so
ever get that
the best we can do is call it pi. It's like we'll give it a name. So there's some magic in giving the unknowable a name, and then it's known.
Yeah.
We go, oh, that's just pie. What are you geeks talking about? That's so boring.
Yeah.
And in that way, you don't have to open the box. You just have it in a box. There's a mystery in the box. It's called pie. And then we can move on with our lives. And the same is true kind of almost all mathematical constants, like Euler's number E, which is used in exponential growth and calculating interest rates, and the base of the natural logarithm. It's another one of those numbers that goes on forever that we don't really understand, that we just call E, lowercase e. And or we say, what if you could take the square root of -1? Now we know you can't really take square roots of negative numbers, because when a square root is which two numbers multiplied together give you that number. And we know that when you multiply a negative number times itself, you get a positive number. So you can't have the square root of -1. Sort of makes no sense. But somebody said, well, what if we just call that I, lowercase I? We'll just call that mystery I and see where that takes us. And then they unlock this whole branch of mathematics called complex analysis.
Based on that assumption.
Based on that assumption of saying, what if we could do the impossible? Where would that take us? And that led to kind of being able to like model fluid flow and make jet engines and do all these things that we take for granted. It never would have happened unless they would have just said, what if we could do the impossible? We'll just call that something. And so that's with pi. That happened a long time ago. They just said, what if we could actually understand the circumference related to the diameter? What if we could let's just pretend that we understand that. We'll call that pi. And so in a way, that's an invention of just saying, we don't really, there's no way to understand this, but let's just imagine that we do.
Yeah.
And then we'll go from there.
What's interesting to me, if I'm understanding you correctly, is I do love that. Like I've thought, that's another one that gets me going, the square root of -1. It's like, sit down and think about that. It's kind of, it does begin to like bake your noodle, as the oracle so eloquently said, that it, you can get yourself into quite a deep twist trying to work that one out, But I wanted to ask you, Scott, do you ever get into those rabbit holes where you start discovering something, you get very excited, you begin seeing more and more and more, and this kind of like acceleration portal happens? I'm thinking about things like, just to give you an example, when I was studying pentagonal geometry and I began to see its patterns all around me, and things like if I cut an apple across the equator, I'd see the 5 seeds. I'd see the pentagonal geometry in the stem of a rose, or in the formation of a daisy, not to mention our DNA, the movement of Venus.
Right.
Blah, boom, 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 boom.
Yeah.
And then you're out to the arms of the galaxy, and then you're going on this, but I always get to a place where my mind just can't keep up with the discoveries. It's like, I want to know it all, but I can't know it all. Do you ever, I'm just wondering, I'm curious, do you ever get struck by that dichotomy of wanting to know and burning out?
Well, actually, I do know it all, so there's no problem there. But I was
actually going to say, if there is anybody I know, that sounds like a kind of a modest joke by Scott, but actually of all the people I know, he probably does know it all.
No, I mean, in truth, it's
actually
I feel the
that
same way. You go down the road as far as you like, and it's a fascinating journey. It draws you along, and you feel this kind of attraction, strange attractor at the end of the tunnel. You go down the road as far as you can, and then you never get to the destination, because you can't get there in a way. You can only approach it, and you have to just take the limit of that and say, well, what if I did get there? How would I feel? And that's in a way, that whole journey and that whole metaphor is encoded kind of even in the constant of pi, in the relationship of a circle to a line.
Yes.
That it's unknowable, ultimately unknowable, and yet we can claim that we know it by calling it pi, and that helps us in some practical ways. But it's the same thing with like physicists. They don't really understand what charge is really, or what mass is really, or what light really is. You know, none of these things do we ever really fully understand, but we just have to draw the line somewhere and say,
draw the line.
We seem to understand it as much as we're capable of right now. And then we'll move on to some other topic. And in a way, it's kind of, it reminds me of like the spirit stitch, or in like, I think Native American pottery, sometimes they would have a vessel that would, they would intentionally like have a flaw in the crack in it or something that would allow the spirit in, you know, was the idea. And to me, with a lot of my research and patterns, I come up with things, it's 99.9% accurate, you know, but it's not exact. And it's the same idea there, that there's a little gap that's left in the matrix to let consciousness in, to let spirit in.
Okay, this is great, because this was going to be my next question, because this is a very pronounced experience I have over and over again with geometry. It's like, I get a really cool idea, I get really excited, I begin to study it, I learn more about it, and usually more discoveries emerge for me, and I get even more excited. But I'm using a particular part of my brain. I mean, I'm not even sure if it's right brain, left brain, but let's call it left brain for this, you know. It's all about receiving insights, receiving information, trying to sort of make sense of them, try to map them onto the world in a way where I can see the patterns, or I can see the archetype appearing. And then I kind of just can't bear it anymore in a way. I don't mean can't bear it, like it's a joyful, pleasant feeling, but I soon get to the stage of like, you know, I don't know the answer to the square root of -1 is the truth. I just, you know, I could try all day long, and then when I surrender, right, it's not like I just sort of hang up my boots and head off and have a cup of tea and go, well, that didn't work, you know. Actually, a much more sublime thing happens in that moment. And now I really like and welcome, because I've sort of done it so much. I know this experience when it's coming. So I get really active. I barrel down the rabbit hole. I have this thinking mind go at full blast. And then I go, and I just dissolve into a very, very different mode of being, basically, you know? And so it's a bit like you speaking about the spirit stitch, or that gap in pi, or there's the Pythagorean comma, I think alludes to this too, where you something else comes in, you know, and that's really like this sort of breakthrough point for me, where it's like I stop thinking. That entire part of my mind just almost, it actually dissolves, like it goes like, so it's not like I stop using it or I choose to put it away. It's just like it evaporates like that.
But then what comes in is kind of a deeper wisdom that comes in. Yeah. I feel like that with that experience is kind of, you have to go down that road, that you have, and it takes energy and you have to work at it. There's an effort, and you go down that road, and you finally come to the end of your journey, and you realize that you just can't go any farther because it's unknowable. And then there's a surrender. And what happens there is, I think it's a invitation for your higher self to give you the information that you're seeking, because you've earned it. You've come to the edge, and now you want more. And then you're going to get this insight or this wisdom that's going to be given to you. You know, and it has to come from a level that's beyond where you are, because you've already exhausted all of the possibilities as far as you can see them. And so in a way, it's kind of like what we're talking about, line and circle together form this kind of binary system that's base 2. So the whole idea of two-ness is not in the binary. It's 0 or 1, but 0 doesn't really understand 1, 1 doesn't understand 0. They're separate, but you need a higher order intelligence to understand them together. It's in a higher dimension, if you will, mathematically speaking. And so as a metaphor, using mathematics as a metaphor, it's just a language. it's a higher level understanding that you have in your higher self. And it's only really able to communicate with you in a way if you do the work and meet it on the edge like that. Yeah. And I think that's what we're trying to do with sacred geometry, is we're trying to take people through that journey to the edge of the known,
where you open then to something way, way more expansive than any kind of thinking part of yourself saying, oh, this is interesting, and a triangle then has these 3 points, and that's great. And it kind of like, it's like getting in the canoe almost, isn't it? And then you paddle away as fast as you can, and soon you just get exhausted with that. And you hopefully you arrive at the island, or I don't know,
you let the river take you,
Yeah, you let there you go. That's beautiful.
Yeah,
that's what it is. Yeah.
And it's not Geoff and Scott saying, okay, now we've worn you out and now we're going to tell you the answer. We don't know the answer.
Yeah, definitely not.
And we're not going to whisper in your ear, like
it's a mystery.
It's a mystery. It's unknowable, and yet it is possible to know it somehow. But it's a connection with a deeper or higher part of yourself that gives you that information.
Yeah. And it's also like, I experience it as kind of a state change, like when I break through into that new place, actually the desire to know is gone. I no longer have this kind of hungry ghost style of, I need more, I need more. It's like, I remember that everything I desire, I already am interwoven in, or is inside me, or whatever analogy works for you. But this is where it gets so beautiful. It's like there's a peace that comes with it, a kind of a blissful feeling, and it's like, I don't need to work out the mysteries of pi right now.
It's because you've broken through into what I would call the intelligible domain, where everything is knowable, and it's a realm of pure intelligence. And so there's your human brain is so trivial compared to the vastness of what is there, that you just surrender it to knowing, to being. You don't have any questions about like what you used to have questions about. All these questions, you're just full of questions. And then you get to this place where you have no more words, you have no more need for questions. It's just a beautiful experience that we've shared. I mean that we've had individually, and yet we compare our experiences and we say, hey, that's very similar to what I've experienced inside as well.
It's so cool. And it's kind of like, the more you do it, the more you can trust it, and I think it's the greatest gift of geometry, really, to be honest. That breakthrough point you get to, but I wouldn't like to pitch this as kind of a destination or an outcome, because then that kind of gets in the way of it as well. Like if I really roll up my sleeves and say, I'm going to break through into the intelligible domain, I guarantee you that I'm not going to get there. It's almost when you can't fake surrender. It's like, oh, I really just give up. I don't know. It'll be in a moment more like that, where I'm nearly just like, I'm dropping the tools, I'm dropping the pencil, and I'm gone. I've kind of had enough.
But I think it's more than just starting with giving up. I think that you get nowhere then. I think you have to go through this period of striving.
Yes.
You have to go through this difficult period of seeking and striving and learning and looking and expanding until you exhaust yourself in that area.
Yeah, I love the two principles of our will, like the individual human will, that we can will ourselves into, learning more, becoming better, discovering amazing insights into some discipline, in our case, sacred geometry. And we can kind of bring ourselves to the books, bring ourselves to the drawing, bring ourselves to the meditations. And you need to build that muscle, that's kind of like tilling the soil of your being or whatever, And then like what happens at some stages, then grace actually comes in. It's like this dance between will and grace. I know that's a funny program in America or whatever, but actually I really like those. They're two heavyweight principles of the universe for me. And you're right, Scott, we do need to do both. It's like, you can't just sit there and go, come on, Grace, you know, show up. It's almost like an interplay between these two forces, will and grace. And it's like you put energy into something, really huge amounts of energy. Then you hit this surrender point. Then something else comes in that you weren't really expecting, or you don't even know. It just, it blindsides you almost, you know. But I do like that dance between those two archetypes.
Yeah, and in a way, that process is sort of like the line of going forward on this line of progress, this linear ladder of progress. You're moving forward. You're advancing along, and then you get this wholeness, this right-brained kind of wholeness. The circle comes in.
Yeah,
you know,
I love that.
It kind of completes it. You know, and it's but you can't just have one without the other. You know, you have they work together. Yeah. And so that's why the circle and the line are such the most important archetypes, I think.
Yeah.
You know, because everything comes out of them. Like a triangle, the next shape is three lines coming, you know, that, and it's you know, it's circles also that come together to form that triangle. When you know, you have to, the way you draw an equilateral triangle begins with circles, you know. And the lines are really just a simplification of that relationship those circles have with one another.
Yeah. I know. Wow. We could go on, Scott. You know, it's like, I just got so many. One of the things I wanted to get to you at the start of this podcast was, you know, lines and the alignment work you've done and all the lines you've drawn on the planet. But you know what? That's going to be a beautiful podcast in its own right, you know. And then I'm thinking about the interplay between circles and lines and Metatron's cube, which is a beautiful dance between these two principles as well. But I am thinking we've filled our time for today. I think, Scott, we've brought this through to a nice place with
hopefully
your gorgeous metaphor.
We've given you some food for thought about something as mundane, seemingly as mundane as a line. Actually has within it the seeds of transcendence, you know, of connection with all that is. It's incredible.
So cool.
When you go from your metaphor as simple as the shortest distance between 2 points.
And
yet you can go on an incredible tangent in getting from point A to point B.
But definitely when you and me are chatting, you know, we can go on tangents, that's for sure, you know. But I'm just thinking you've really struck a chord with me with that metaphor now of the line kind of representing will and the circle representing grace, you know, and the interplay between those two with pi mixed up in it. It's kind of gorgeous, you know. But thank you, Scott. Always a pleasure. You know, I could talk about geometry till the stars fall out of the sky, to be honest, you know. And it's always a pleasure talking to you. Let's keep doing these podcasts. We hope you're enjoying them. You know, dear listener, I always like to thank you if you've listened all the way through. I bet you have a similar resonance to us if you're liking this stuff. And it's very exciting to think that we can share it with you. So keep listening. We'll have more episodes coming soon. Thank you. Thank you, everybody.